Here is our EE599 final project report. We are Team Lakers. I'm Dasun.
I'm Xinghui.
Okay, for first part is the overview. This project focuses on using data structures and graph search algorithms to build a mapping application. And we can see here there are several parts here. And the first part is the node class. We can see it on the right. And the second part is autocomplete. And the third part is find the place. And the fourth part is calculate the shortest path. Here we use digestion and Bellman-Ford here. And the final part is traveling children problem. We use brute force and 2-opt heuristic here. And this is the implementation of our menu item.
In this autocomplete function, we take the partial name of location and return a list of possible locations with partial name as prefix. I also extend this behavior so that it also shows the place that contains a search string, not just with prefix. Here I will give some example. The first example here, let me type in CA. As you can see, these results are case insensitive. Second, let me type in TER. It's also case insensitive, and as you can see, these results are locations which contains the TER.
For the second function is find the place. Here I use an iterator here to traverse the data map to find the target location, and the time complexity here is of n. We can see that on the left, this is our location on the map, and on the right is the target on the Google map. Here I will give a quick live demo, like our typing target. And you can see on the left it is the location on the map, and on the right is the latitude and the longitude here.
To solve calculate shortest path problem, I gave two kind of solutions. The first one is digestion. The second one is Bellman-Ford. Digestion algorithm uses a strategy of greedy algorithm. In every time of iteration, one node which has the shortest distance will be extended, and we will update all its neighbors. When all nodes are extended, we can get shortest distance and path. For Bellman-Ford algorithm, it can handle graph which has negative edges. However, we didn't take this advantage. For time complexity, digestion algorithm is O of n squared, and Bellman-Ford is O v multiply e, which v is the number of vertices and e is number of edges. The time takes here for digestion is about 4 seconds, and for Bellman-Ford is about 45 seconds. So I will only give example of digestion. Let's say from refs to target. That's the result. We can compare it with Google Map result. In this function, I have two tricks. The first one is to set a map to record nodes precursor load. The second trick is to decrease running time. We can break the digestion loop once we have found the shortest distance to that destination.
For the first part is traveling children, and the first one is brute force. Here we're just evaluating all possible permutations and find the global minimum. It's a little bit time consuming here, and the time complexity here is of n factorial. For example, if we have input for more than 11 nodes, we will have more than 15 seconds for this function. And we use DFS and backtracking here to realize all possible paths. And we use pruning when finding that the current cost is already bigger than the minimum cost. Here I'll give a quick live demo. Like I'll put input like 10. And you can see on the left is the animation. And on the right, we also have the result here. Okay, here's also the animation. And for the second one is a 2-opt solution. And here I just use 2 for loop to traverse and remove 2 edges and reconnect them to find an improvement on total cost. And 2-opt is heuristic, and it can just find a local minimum instead of global optimum. But however, it's a little bit fast. It's much faster than the brute force solution. The time complexity here is of n squared. So let me give a quick demo here. Let me just like input 30 nodes. You can see the animation is on the left. It's calculating right now. And you can see the result. Okay, so that's all for our presentation. And thank you for your listening.